Everyone, and welcome back. Today we're going to switch over to another math video, and we're going to be diving into a little bit of a harder topic, one that you might encounter in Algebra 2. So let's go over ellipses today. Today we're just going to be solving a problem that I have set out, and through this problem we are going to look at all the different equations that are going to help us to solve this problem regarding ellipses, of course, and then we'll look at some topics that refer to ellipses, such as eccentricity and major and minor axis, vertices, and foci. So let's get started. First thing that I'm going to do is I'm just going to write out my equation right here. Oh, actually, I'll read the problem first. So our problem is find the vertices, foci, and eccentricity of the ellipse with the equation x squared divided by 4 plus y squared divided by 25 is equal to 1. So I'm going to write out the problem here. X squared divided by 4 plus y squared divided by 25 is equal to 1. Okay, so now that we have our problem written down, let us go into what type of ellipse this equation will yield. So we notice a few key things about this. First of all, if we look at this diagram given by Cengage we can see that both of the ellipses yield different equations, and the only difference that I can spot is that a squared and b squared just come under different variables. So we know that a is always going to be greater than b, which is always going to be greater than 0. So we know that a is going to be our larger number in the equation. So a squared, depending on its position, if it's under x squared or if it's under y squared, will yield a different orientation of our ellipse. So let's look for the larger number in our equation. Clearly see that it's 25 as compared to 4. So we know that we're going to be looking for our a squared under our y. So we will be looking at this equation. So we know that we're going to end up with a vertical ellipse. So we can highlight this equation, do whatever you need to do with this equation, but know that we're going to be using this one for this problem. Similarly, we'll just be following along in this column to look at the different vertices, foci, and eccentricity will come later. Okay, so let's get started. The first thing that we have to find are the vertices. So I'm going to write down our vertices right here. So if we scroll here, we can see that our vertices are equivalent to 0, plus or minus a. So we don't know what a is right now, 0, plus or minus a. Okay, and if we go back to our equation, we see that a squared is under y squared. So we know that 25 is equivalent to a squared. Okay, well, we know a squared, we just don't know a. So in order to bring 25 to a, we have to square root 25. So, and also we have our plus or minus in front of here. So we know that our vertices are going to be 0, plus or minus root 25. And if you know the answer to this, pause the video right now, write it down, and see if your answer is correct. So the correct answer is 0, plus or minus 5, which we will write out separately as 0, 5 and 0, negative 5. So these are our vertices. And it gets as simple as that. You just plug some numbers into an equation and you get your answer. So next up, we're gonna be moving on to our foci. Now, if you've never seen foci on a graph, there are these two little dots right here. And if I forgot to mention, our vertices are gonna be these dots right here that fall upon the axis. And then B, right here, is the number that you see under our x squared. So it's going to be our minor axis. This is our major axis. This is our minor axis. Okay, so I'll erase all of this drawing from the graph, but we're focusing on the foci. So this is our foci. Now, how do we find foci? So if we're still looking at this column, we can see that foci corresponds to this equation. So we know our foci are going to be 0, plus or minus c. We just don't know what c is yet. But we can find c, so let's write down this equation. C squared is equal to a squared minus b squared. And you'll see that this equation, c squared is equal to a squared minus b squared, is even the same for our foci on the horizontal ellipse. It's just the position of c in this case is going to be in the x, position of c is going to be on the y, which makes sense because our y-axis contains the foci, and then our x-axis contains the foci in this case. Okay, back on track. C squared is equal to, where do we get our a squared and our b squared from? Well, they're going to be right over here, so we hop on over to our equation, and we see that a squared is equal to 25, b squared is equal to 24. So a squared was 25, b squared was 4. C squared is equal to 21, which means our c is equal to plus or minus root 21. And if we want to put it into this form, we're just going to have to translate it into 0, negative root 21, 0, positive, you don't have to write the plus, but if you want to, you can, 0, positive root 21. This is as simple as it gets. Like I said, you're just plugging a couple of values into your equation, and then it doesn't seem so hard. And finally, we're moving on to eccentricity, which I will describe right here. So eccentricity, you might be confused as to what it is. I'm just going to go over this image from Cengage Learning so that we can know a little bit more about it, and then I'll define it for you guys. So, definition of eccentricity. For the ellipse with the equation x squared divided by a squared plus y squared divided by b squared is equal to 1, or x squared divided by b squared plus y squared divided by a squared is equal to 1, and we're looking at this equation. With a is greater than b is greater than 0, we know that this always has to be true. The eccentricity E is the number. E is equal to C divided by A. And remember that we already have defined these values, C and A, so it's going to be super easy to find. One quick note before we continue. The eccentricity, it doesn't matter on your equation, x squared divided by a squared plus y squared divided by b squared, or the placement of b squared and a squared. The only values you need to know are C and A. Okay, so it tells you how to find C here, where C is equal to square root of a squared minus b squared, which is basically what we did right over here. The eccentricity of every ellipse satisfies E is greater than 0, but less than 1. So this is super important. We cannot have a negative value, but it also cannot be greater than 1. So if you're still confused as to what eccentricity is, eccentricity basically determines the shape of your conic. So eccentricity in simplicity, that rhymes, is the distance from the center to C. C is our foci, the ratio of the distance from the center to C to the distance from the center to A. So if we draw our ellipse right here, and I know it isn't that great, but if our foci are right here and our vertices are right here, eccentricity is the ratio from the center to these points, and then from the center again to these points. And basically what that is, this ratio determines how circular our conic will be. So like I said, it determines the shape and how circular. Okay, so now let's solve the eccentricity for our equation that we were given first. X squared divided by 4 plus y squared divided by 25 is equal to 1. So I'm going to write that here. X squared divided by 4 plus y squared divided by 25 is equivalent to 1. And we know that our eccentricity, E, is equal to C divided by A. Now we just have to scroll up a little bit to find our C, and we know that it's plus or minus square root of 21. So we're faced with a decision here. We can choose plus or minus square root of 21 divided by, and then our a, as we determined over here, is going to be plus or minus 5. So plus or minus 5. Either way, remember what we said here. It cannot be a negative number. So e, we're going to have to choose the positive value. So this is going to be square root of 21 divided by 5. So we automatically cross out the negative signs from here so that we remain with our positive values, because we know that it has to be less than 1 but also greater than 0, meaning no negative values. So this is our eccentricity. And again, super simple. You're just plugging in values to an equation that's already there. And especially with conics, I'd say that the most important part is if you don't want to memorize it, know how the equations work and how the equations are structured. And then if you have that in your mind, then you'll be able to solve any equation that comes your way. Okay, and finally, our part B of the problem. Determine the length of the major and minor axis. So let's start with our major axis. Major axis. So if you're wondering what a major axis is, it's basically the distance between our two A's, our two vertices. And this is the major axis because you can clearly see that the ellipse is kind of longer on this side as compared to the length of this side of the two B's as compared to the two A's. So simply put, the major axis for this one would be the horizontal length, and the minor axis for this horizontal ellipse would be the vertical length. But we are looking at this one, so the vertical length would be our major axis because it's clearly longer on this side. So our major axis is going to be 2a. So let's scroll down, write this, 2a is equal to, and if we want to find our a, we can scroll back up here. We know that our a is going to be 5, and again, this cannot be negative because a distance or a length cannot be negative. So 2a is equal to 2 times 5 if we're plugging in our a, and then we get 10. So this is your major axis length. You can also think of it this way. So we know that our distance, let me erase all of this so we can look at it clearly. So we know that our A is equal to 5, right? Let me get a thinner pen. So our A is equivalent to 5, which means that there must have been 1, 2, 3, 4, and then 5 up here. But in total, this distance also equals 5, which means that this distance also has to equal 5. So if we want to find the length, we can just multiply these two we can just multiply 5 by 2 because there's two sets of 5, first set, second set. In order to find the total, we just multiply by 2 and we get 10. So that is basically your major axis. Now let's move on to minor axis. Oh, that is a smaller pen. I believe it is this one. Yes, minor axis. Now remember, I said minor axis was 2 times b. And in this case, it's going to be the horizontal length. So let me erase this so we can get a clear look. Okay, so our minor axis. So what did we determine b was? So b squared is equal to 4, which means that b is equal to 2. Because if we take the square root of 4, we get 2, plus or minus 2. Okay, either way, let's determine this. So we have 1, and then our second tick is going to be over here, because this is negative 2. This is positive 2. But either way, our distance from here to here is going to be 2. We take the absolute value for distance. And then if we want to find the cumulative distance, we just multiply 2 for 2 times, because we have set 1 here and set 2 here. And then, remember how our equation was 2b, we're simply plugging in the 2 value that we have here into our equation. So essentially, we just get 2 times 2, which equals 4. So we're going to go scroll down, plug in 2 times 2, and then we get 4. So this is our minor axis. And that is the summary of our lesson. Let's go over what we did today. So we started off by looking at our problem. X squared divided by 4 plus y squared divided by 25 is equal to 1. And our entire lesson is based off of this problem today. And then we took a look at this very helpful chart. We determined what the vertices, the foci, and finally the eccentricity of this specific ellipse was. We also defined these terms in the process. And then we took a look at the length of the major and minor axis specific to this ellipse. Now I know that we didn't go over the horizontal ellipse today, but if you would like me to do another problem on that next week or personalized to your problem, if you have any questions on a certain problem, you can definitely send it to me. I'll do my best to respond and send you guys helpful videos that could possibly solve your problems. In either case, please like this video, share it with anybody who might benefit from it, and comment down below what you would like the next few videos to be about. That sums it up for today's lesson. Thank you.